everyone. We are back for a new episode of the Zero Europe Live series of webinars. You're already 22 people, 24. We'll just wait a few minutes to have all the participants joining, and we'll start in. So, new topic, new episode, new topic, and I'm quite happy to have today two great speakers, experts to help us understand the transition strategies when it comes to dealing with residual waste. When defining the topics for this year, we ask you the conversations that you would like to have, and residual waste was quite high in the top priority list of priorities. So as usual in our webinars, we'll have some time to discuss, hear from our experts, and then have time for conversation. So I'm Esra Tat, I'm the Network and Development Coordinator at Zero Europe. And as explained today, our topic is transition strategies to deal with residual waste. As we know, recycling rates are increasing, and we do fight waste generation. So the burning question that we have these days is, what do we do with residual waste? But also beforehand, how do we detect and eliminate non-recyclable waste? Or how do we set up a research center to deal with this question? We have actually quite a lot of questions already from the people who registered. And to dive into the topic today, we have Enzo Favoino with us. So if you already attended the webinar, you've seen Enzo in the past. Enzo, he is the scientific coordinator at Zero Europe, and he's a technical expert and a researcher at the Scuola Agraria del Parco di Monza in Italy, and has decades of experience in separate waste collection, recycling, composting, and prevention. So Enzo will give us the perspective of residual waste both from European and broader perspective, including some information on the legislation. After Enzo, we're lucky to have Dominic Hug, who is the chairman at Eunomia Research and Consulting. Dominic has this appetite for as he would say, the market mechanism that work to incentivize citizens and businesses to make the right choices, ensuring that people who do the right thing are rewarded commercially and financially. So Dominic is going to guide us in the question of the climate impact, and actually a broader understanding of this material recovery, incineration topic as well, but this time more from a global perspective. So you know a bit of us, and we'll be also happy to hear about who you are. So you have a chat box, and my colleague Agnese has already started to write a bit. We invite you to just say hi, who you are, where you're based, where you join us today, so that we also have an understanding of who are with us today. And also second point, so you do have the chat box just to say hi, and we invite you to use the Q&A section to send your questions to the speakers. So for this topic that is rather technical, we decided to allow more time for our speakers. So Enzo Favoino is first going to speak with a 20-minute presentation. Feel free to send all your questions, to drop your questions in the Q&A. We'll then move to Dominic Hug and keep more or less an hour conversation based on your questions. So thank you very much. And without further delay, I leave the floor to Enzo Favoino.
Thank you, Esra. Good morning, everybody. Let me share my screen so I can start my presentation. Can you see my screen?
Yes.
Wonderful. Let us set the scene first. And since we know we have got a global audience today, really an impressive set of participants in this webinar, I will be making reference sometimes to the European situation, since it is really setting the scene when it comes to advanced waste management, in particular thanks to the recently approved circular economy package. But of course, I will always try to make reference to more global issues and a wider context. Anyway, setting the scene. The circular economy agenda, not only in Europe, but also in other parts of the world, everybody's discussing about circular economy, sustainable material management, and this is setting the bar higher. It tells us we have to keep ambitious when it comes to material recovery rates. In particular, we have got an European communication issued by the European Commission on the role of waste to energy in circular economy. And it disclosed, it was dwelling on the possible tensions at the interface between infrastructure in thermal treatment, such as incineration, and the need to have higher and higher material recovery rates. Then we have got a plastic strategy, which was adopted by Europe as a framing document when it comes to management of plastics, and a soon to be issued directive on single-use plastics. And both are pushing for redesigning for better durability, recyclability, reusability of materials, and phasing out of those hard to recycle plastics, which most often end up in the open environments. And then there is an ongoing revision of the mechanisms in Europe to allocate regional funds. Basically, they will be very likely taken away from investments in infrastructure for the management of residual waste, be it landfills, be it MBT sites, be it incinerators. And this for sure will make residual waste management more expensive and therefore driving efforts and energies towards material recovery. We know that zero waste is a toolkit. It's the perfect toolkit in order to turn the vision of circular economy into operational reality. And we always say that zero waste is more the journey than the destination. But this implies that we never get satisfied with the levels we are at, because we have to be more and more ambitious, and we have to improve recycling rates, we have to reduce waste amounts, we have to minimize residual waste. And this all calls for flexibility in the management of residual waste, because the dwindling amounts of residual waste can't cope with infrastructure which is inflexible. For instance, this is a chart which reports on the trends in waste management in the first European municipality which adopted a formal zero waste commitment, namely Capanori in central Italy. And as you can see, first they introduced the curbside schemes, including the organics, which increased the recycling rates and reduced the total waste amounts and the unit waste arisings in kilograms per inhabitant and year. A couple of years later, they also introduced pay-as-you-throw systems, which caused a further increase in the recycling percentages and a further decrease in the unit waste arisings. So in the end of the story, the system is moving towards minimization of residual waste, which once again calls for systems for the management of residuals which can cope with the dwindling amounts of residual waste. But also, if we take a look at the average national data, this is a chart from a few years ago. Let me draw your attention to the data from Slovenia. Slovenia, a few years ago, was at 40%, which was already quite a promising result for an enlargement country, a Central Eastern European country, which was still implementing all the strategies coming from the body of European environmental policy. But just a few years later, if you take a look once again at Slovenia, Slovenia is jumping on top of the standings for Europe and for the global rankings when it comes to recycling rates. And this is basically related to the fact that they have got a very low reliance on incineration, which is the green part of the bars. Let me try and use the pointer. Here you can see a very small part, which is reliance on incineration, which is keeping the system flexible, and therefore they can fully deploy the potential of zero waste programs, circular economy, and so on and so forth. By now, Slovenia should already be around 65 to 70% separate collection. Also, if we take a more detailed look at some districts, waste management districts. For instance, the planning units in Italy are the provinces, which are basically corresponding to counties in the United Kingdom, Landkreise in Germany, prefectures in France, and so on and so forth. You can see that there's already a good bunch of provinces above 80%, and some of them are already down at 50 kilograms per inhabitant and year residual waste. And you know, if a province totals a population roughly of 1 million people, this means that residual waste is just as little as 50,000 tons. So a few years ago, with 200 or 300 kilograms residual waste per inhabitant and year, residual waste was at 200,000 tons. But with as little as 50,000 tons, in a planning unit such as a province, it's hard to consider incineration with such a low amount of residual waste. So what shall we do with residual waste? Because anyway, we have got some residual waste to manage. We need a transitional strategy for residual waste, and this is a global problem, of course. While we pave our ways towards zero waste, we still need to make decisions on transitional strategies for the management of residual waste. There are a few problems with incineration in an ever-changing context. We have got the increasing importance of secondary raw materials in order to replace primary raw materials. We have got the resource scarcity crisis, and this is drawing attention to maximization of material recovery. We have got drivers and directions which are coming from international policies with an increasing importance of reduction and recycling in order to maximize efficiency in the management of resources. Increased targets are already adopted in Europe and are likely to be adopted elsewhere. There is a decarbonization of energetic production, which means a decreasing marginal value of energy we recover from burning waste. But Dominic Hogg will dwell on that a little bit longer in his presentation. We have got these dwindling amounts of residual waste, and therefore we have got some financial risk connected to incineration. It's basically, first and foremost, it's a problem of incurring financial risks. Right now, investing in incineration is at risk of incurring financial tensions. In Europe, anyway, we have got a landfill directive adopted in 1999, probably the most important driver in waste management and related costs during the years 2000s, because it not only mandates reduction of biodegradable municipal waste to be landfilled, but most importantly, it sets an obligation for pre-treatment of the waste to be landfilled. And this is extremely important because, first of all, it minimizes the impacts connected to landfilling, but also it makes landfilling more expensive, which is a further driver to make separate collection and recycling cost competitive. This is why it was one of the main drivers for evolution in the system of waste management across Europe. But this calls for some type of pretreatment of residual waste, of course. Let's take a look at the way residual waste looks like. And let's go back to capannori, which I already mentioned. Capannori at present is around 85% separate collection. This is a situation which is fairly widespread by now in different areas across Europe. Whenever you implement zero waste programs, you roll out a curbside scheme, you include the organics, and you adopt a pay-as-you-throw system, and you may get quite easily well above 75–80% separate collection. But the main effects on the composition of residual waste in capannori is that there is a sharp reduction in the percentage of organics. So let's keep it in mind, because this will affect the possibilities for the management of residual waste and the connected needs. And there is a concentration of other materials, such as plastics, because not only those plastics which have not been captured through separate collection. Separate collection relies on behavioral change, and so much as we target perfection, we have to live with imperfection in daily behaviors by people. But there is also, most importantly, the effect of non-packaging plastics, which are not covered by EPR, by extended producer responsibility, and therefore they tend to end up in residual waste, and they concentrate there. quite often we find 20, 25% and even more plastics in residual waste. And, and then another 10 to 15% paper. This is also another important concentration effect of materials which might create some scope for further recovery of valuable materials inside residual waste. So what might be the goals for a consistent residual waste management strategy? We may consider maximizing recovery of materials in order to get aligned with the circular economy vision. We have to minimize reliance on landfilling, of course. We have to minimize the impacts of landfilling as well. And so we have to minimize fermentability of whatever gets buried into a landfill. But most importantly, we have to keep the system flexible and adaptable in order to cope with the ever-increasing recycling rates and the ever-decreasing and minimizing amounts of residual waste. This is why we defined a concept which goes under the acronym of MRBT. It stands for Material Recovery Biological Treatment. There is a study you may download free of charge from the Zero Waste Europe website. That's a life cycle based study, and therefore it basically dwells on the impacts and environmental benefits of material recovery and biological treatment, whereas during current presentation, I will mostly dwell on the operational implications and what is the operational potential of material recovery and biological treatments. So the operational goals, we have just seen the strategic goals, but the operational goals may be to recover metals, both ferrous metals and non-ferrous metals. This is one of the easiest things to be done, and it's ordinarily being done at whichever type of residual waste management site, since it's quite cheap and easy to recover metals. We may recover some high-value polymers still included in residual waste, such as HDPE, PET. We may recover some board and some paper, which is still included in residual waste. And we also have to consider stabilizing organics before landfilling in order to minimize fermentability of what gets landfilled. So if we consider a flow sheet for traditional mechanical biological treatment, MRBT, material recovery biological treatment, is pretty much similar to mechanical biological treatment. And this gives the potential for a conversion of many of the existing mechanical biological treatment sites into material recovery biological treatment sites with not such big expenditures. You can see with a traditional MBT type of scheme, we have got residuals. They undergo some screening, it's dimensional separation. These screens out the fines where dirty organics are included. They show high moisture and fermentability. They may undergo biological stabilization, which is nothing more, nothing less than a compost like type of process. It therefore has some process losses, water vapor, carbon dioxide, and in the end of the story, we have got a stabilized organic fraction with reduced fermentability. On the other hand, from primary screening, we have got the coarse materials with a low moisture and low fermentability, and they may be landfilled as they are, as a low fermentability material, or traditionally, most often they were undergoing some density refining in order to produce some RDF, refused derived fuel. There are some rejects from density refining. This is a typical mass balance, 20% rejects, 15% mass loss, process losses, water vapor and carbon dioxide, 40% RDF, and 25% stabilized organic fraction. So in the end of the story, what goes into the landfill body would be 25% stabilized organic fraction, 20% rejects, and in case you don't refine RDF, also 40% RDF. But the most important is that the stabilized organic fraction underwent biological stabilization, and therefore fermentability and the impacts related to fermentability are minimized. With MRBT, you have got a change in the operational scheme for the coarse materials, and they undergo some sequential selection, such as ballistic separation, in order to separate bidimensional materials, such as some plastic sheets, some cardboard, and three-dimensional materials, such as barrels, cans, and so on. Then on both streams, you may have magnetic separation, optical sorting in order to recover some paper and high-value polymers, manual separations, for instance, for the big plastic sheets, extrusion for the low-grade mixed plastics, and so on and so forth. And so you may enhance and maximize recovery of materials. Of course, also from separations, you tend to have some rejects which will have to go into a landfill. So in a summary scheme, material recovery biological treatment consists of two different sections. One is made of equipment in order to select different materials, and one is made of technologies for biological stabilization, which is similar to composting. So you understand that both may be, at a later stage, be applied to materials coming from separate collection. Clean organics from separate collection of organics, or plastics coming from separate collection of plastics. So still keeping the financial balance, a financial viability of the system, you may work on dwindling amounts of residual waste, having them replaced by clean materials coming from separate collection. These are some very quick examples of ballistic separation, the previous one. This is an optical sorter. Then you may have the end-of-line rejects from the optical sorting lines, which is basically mixed plastics. And I find it harder to call them rejects. And actually, they may undergo some extrusion. And this may turn them into durable materials, such as pots, such as drainage pipes and similar materials. These are leads for manholes being used in place of the steel ones, and meeting the relevant standards for the sector. But as you can see at the bottom, they have got wooden pallets, so you understand what I'm thinking of. What crosses my mind is the possibility to use such mixed heterogeneous plastics also to replace wooden pallets by means of plastic pallets. So it's always durable stuff which may be used again and again and again. Or building blocks, this is Conceptos Plásticos. It's an initiative coming from Southern America to make housing also for poor people who can't afford having traditional houses. So in the end of the story, you know, they may meet relevant standards and they may be used for different applications. There are two preconditions for material recovery biological treatment to work efficiently. One is technological evolution of dedicated equipment. By now, we have got very good potential recovery rates for cellulose-based materials such as mixed paper and board. Very high possibilities for optical sorting of different plastic polymers. Highest sorting possibilities for metals. For glass, it's lower. But another underlying condition is to have a very low percentage of organics in residual waste, because organics in residual waste makes residual waste dirty and sticky. And therefore, the efficiency, the operational efficiency of the equipment would be low. But with ongoing implementation of separate collection systems for organics, it becomes more and more possible to work on residual waste. These are the typical percentages of food scraps in residual waste from curbside programs as rolled out in southern parts of Europe. So you understand that with organics around and below 10%, residual waste becomes much more workable than it traditionally was. Also consider that in Europe, there is a specific driver for separate collection of the organics, as established by Article 22 of the new Waste Framework Directive, which stipulates an obligation of separate collection of the organics starting with 2024. So such situations will be more and more widespread. So let me go to the end. Examples of such approaches. This is a site based in Este, in northeastern Italy. Here you have well, it's basically an operational complex. They have got anaerobic digestion, they have got composting of clean organics, they have got their own landfill, and this is the material recovery biological treatment section. It started with 90,000 tons a year residual waste, and now with increasing progresses of separate collection, they only treat as little as 30,000 tons a year of residual waste and 60,000 tons of plastics, papers, and metals coming from separate collection in order to sort them into different polymers, different grades of paper, and so on and so forth, still keeping the financial viability of the whole system. But a few remarks to end with on the mass balances. Basically, recovery of materials is already fairly diffused at mechanical biological treatment sites, even the traditional types of MBTs. From the easiest and least recovery types, typically metals, to more ambitious ones targeting metals, plastics, and paper. The drainage of organics from residual waste is disclosing further and further opportunities. The amount of rejects after MRBT is still remarkable. You have seen from the mass balances I had shown a while ago that 50 to 60% of materials of residual waste is still going to a landfill. But this is the very reason why we give priority to separate collection. If we were able to meet 90% recovery from residual waste, there would be little scope for separate collection. But first and foremost, we want to run separate collection systems, minimize residual waste. In the end of the story, waste we send to landfills is stabilized, and always remember, we are landfilling tonnages and not percentages. Consider, do you eat more if you get 100% of a cookie or if you get 30% of a cake? And you know what the answer is. 30% of a cake fills you much more than 100% of a cookie. So basically, what we have to do in order to minimize landfilling is to keep the system flexible so as we may work on minimizing residual waste so that percentages of rejects from management of residual waste apply to dwindling tonnages of residual waste. Here you can see a comparison of two typical situations we are having across Europe. These are data taken from reality, from real life. There are areas in Europe with 750 and more kilograms per person and year municipal solid waste. 52% of that is incinerated, so 400 kilograms is going to incineration, and 25% of that is made of slags and ashes, which makes up a staggering amount of more than 100 kilograms per inhabitant and year slags and ashes. In a zero waste district, they are only producing as little as 350 kilograms per inhabitant and year. 85% of that is recycled, so residual waste is just as little as 50 kilograms per person and year. But above all, since they have got no lock-in effect, because there is no incinerator there, they may keep working on maximizing separate collection rates, minimizing amounts of municipal solid waste. And so they are committed to reduce residual waste by a further 80% in next few years, going down to 10 kilograms per person and year residual waste to landfill. So in the end of the story, what's most important is to keep the system flexible, to keep working on minimization of residual waste. So let me put the icing on the cake. What might be the benefits of what we call the cool treatments, material recovery biological treatments? It's scalable, because it's any type of treatment which is based on biological treatment and some mechanical sorting is already affordable in the magnitude of a few tens of thousands tons per year. We've done preliminary surveys and feasibility studies for sites as small as 20,000 tons per year. It's cost competitive when it comes to capital expenditures. It's in the region of 250 to 300 euros per ton of installed capacity at BAT level. Whereas with incineration, you may easily go up to 1,000 euros per ton of installed capacity. This is the specific capital expenditure. It's fast to implement, which is extremely important in many areas of the world, because it may give you prompt compliance with the need to have pre-treated waste going into a landfill, therefore improving by far the management of landfills. But above all, it's flexible, adaptable to increasing amounts of separately collected materials and decreasing amounts of residual waste. The last one, not everything is perfect. Still, we have got much to do in this respect. Of course, we have to minimize organics in residual waste. This is why we promote, another reason why we promote separate collection of organics. In Europe, this will be driven in next few years by the obligation for separate collection stipulated by Article 22 in the new Waste Framework Directive. We may improve the recovery rates from such types of management of residual waste. Above all, there is a very big potential thanks to extrusion of low-grade plastics coming at the end of the optical sorting lines. And we have to consolidate the markets for second-hand materials. Above all, in the green public procurement sector and through the minimum recycled content driver. So establishing minimum percentages of materials coming from separate collection, recycling, or mechanical sorting of residual waste to be used in different sectors. And there are some sectors, such as the automotive sector, with a huge potential of absorbing materials coming from such types of recycling. So thank you very much for your attention. This should be an eye-opening picture of the amount of residual waste which was produced in 1 year by one pretty famous zero waste campaigner over here in Italy, Linda Maggiori, namely Linda Maggiori. She produced 0.5 kilogram residual waste in 1 year, which has to remind us that we have to avoid strategies and infrastructure which would cause a lock-in the planning strategies for waste management. Thank you very much for your attention.
Thank you very much, Enzo. I invite you to stop sharing your screen. Thanks a lot for the overview and this deep dive into the MRBT question. We have a couple of questions of clarification. I just wanted to put some emphasis on what you mentioned, that of course our priority is to minimize residual waste, is to increase separate collection. And the core of the question today, and actually the report that you mentioned about the leftovers, the main question is, what is the best method for managing this residual waste in order to reduce the harm and risk for public health and environment? And I think it's very important that we remember what you just mentioned, that we should not find ourselves in lock-in situations with investments that would actually will prevent us from doing the right thing, which is minimizing residual waste, increasing separate collection. This said, there are two clarification questions that I would like that we address now before moving on to Dominic. So Alexandra is asking in the Q&A section, hi, do I understand correctly that a MRBT plant can be used alternatively for processing the different streams coming from separate waste, organics and plastics, etc.? Enzo.
Spot on. That's precisely why we are promoting this type of approach, because it keeps the system flexible. Actually, in the bird's eye view from an MRBT site I have shown during my presentation, that's a site which is processing on different shifts, different working shifts, residual waste and materials from separate collection. At present, they are processing 1/3 residual waste and dwindling, and 2/3 materials from separate collection and increasing, of course.
Thank you very much. There was a question, I think it was one of your last slide, a question from Jacques. He's asking, the 250 euros per ton is the investment necessary or the operational cost?
No, it's the unit investment cost. I know that's always at risk of confusion because we normally consider gate fees. But it's important when discussing the management of budgetary resources also to consider the capital expenditures. So that's the unit capital expenditures per unit tonnage of installed capacity. So when you say 250 euros per ton of installed capacity, if you consider for instance, 100,000 tons residual waste management site, the cost would be 25 to 30 million euros. With an incinerator and the unit capital expenditures of 1,000 euros per ton of installed capacity, the cost of incinerator would be, for the same size, 100 million euros, not 25 to 30. Then, of course, also the capital expenditures turn into a component of the operational cost by means of technical and financial depreciation. But this would require a different webinar, of course, to discuss.
Thank you very much, Enzo. There are two questions that could be actually kept for the longer conversation after, but there was a clarification question from Fernanda in the case of Italy. Fernanda is asking, the pre-treatment residual waste is financed by governments? Is it financed by governments? And is mixed plastic becoming recycled item these days in Italy?
Yeah, very quickly, and then we may give details during the final debate. Well, in Italy, just as in other parts of Europe, residual waste management has been so far granted by European regional funds and cohesion funds in the southernmost regions of Italy, such as Sicily, Campania, Calabria, and so on and so forth. This is going to be phased out if the current proposal from the European Parliament will fly. Because as you know, the European Parliament has proposed to move the regional funds up the hierarchy, phasing out any funding for residual waste management, apart from a very few exceptions for outermost regions. So basically, all the types of residual waste management will have to be paid by the users, be it the member states, the regions, the provinces, municipalities, and so on and so forth. And this will make even so more the capital-intensive technologies such as incineration more and more expensive, also when it comes to operational costs. And when coming to the use of recycled plastics, yes, they are already being used for many different applications, including the mixed plastics coming from densification and extrusion processes. For instance, there was a famous case in Pontedera, maybe you know Piaggio, which is a quite comparatively famous motorbike make. And they were using such plastics for the shapes of the Vespa motorbikes. But that was not done in order to make it more green. You know, they never used a green argument in their marketing strategy. That was done by them in order to make it secure the supply of materials for their production processes, because we are in a resource scarcity crisis. And this is becoming more and more important. But that's what we have tabled on circular economy package.
Thank you very much, Enzo. I'll keep the other questions for the longer conversation. And I'm happy now to leave the floor to Dominic Hogg, who's going also to help us understand the global perspective as well on the question on residual waste. So Dominic, please unmute yourself, share your screen, and we'll have also 20 minutes of presentation.
Okay, thank you everybody, and yeah, great to have everybody online today, and welcome. Thanks for coming to listen. I'm just sharing my screen now, so I hope this is coming up. Can you let me know when it does, Ezra?
Yes, perfect.
Okay, great. So thanks, Enzo, as well, my blood brother. And so it's nice to be doing this together. I'm going to be talking a little, following on from what Enzo said, a little more about some of the technical stuff. Very brief bit about us. I'm not going to spend time talking about that, but I suppose the important thing for me is we've been doing this for a long time. We've been looking at this question, much as Enzo has, for a long time. We were always challenged in the past as we were developing high recycling strategies. People would say, yeah, but you can't recycle 100%. And so the way we came at this, I suppose, was, well, can we really say responsibly to everybody, just carry on landfilling? And we know the problems that can create. And so it challenged us to look for ways in which we could deal with the unrecycled waste that was not going to be problematic, but on the other hand, didn't prevent the further progression in the performance of the recycling system. And that's where we're trying to go with zero waste. And so we've been this presentation is based on quite a lot of years of experience of doing that. Just a very brief reminder, and this is partly because I'm going to be concentrating here on the greenhouse gas impacts of these different technologies. Enzo's covered very well some of the key issues around why you choose certain things. But we did this piece. It was again for Zero Waste Europe. You can find on the website. It was around greenhouse gas and climate change impacts of waste treatment. And you know, lots of people would talk about the benefits of using incineration because of the energy you generate. But you know, once you're at the bottom of the hierarchy, you're really playing with the crumbs. Not the same biscuit as Enzo's, but it's crumbs nonetheless. And it's here where the action is, and here in terms of avoiding waste production and recycling. This is where we get savings in the greenhouse gases associated with recycling and waste prevention. Always interesting to look at this one. People often draw attention to this. Hey, you know, anaerobic digestion, you don't get such a major benefit from the greenhouse, from the treatment. No, but what we also find is when people are provided with separate food waste collections, they tend to be more sensitized to what happens to that food waste. And so they tend to do more by way of minimization. And for every ton of food waste we're preventing, we're saving a significant quantity of greenhouse gases. So it's a system effect. And in terms of resource use, I love this diagram. I love this diagram because we tend to think in terms of recycling rates as, okay, if I go from 50% to 60%, I've increased my performance by 10%, and then I go and I increase it a further 10%. But if you look at this in terms of the additional things that you can manufacture from the initial material, once you get to 50%, you can do twice as much with the material as you started with. We've got to go into this steeply sloping part of the curve, though, if we really want to get the benefits. Because once we get to 80%, we can make 5 times as much stuff with the original material as we could when we weren't recycling any. And when we get to 90%, we can make 10 times as much. So we're doubling we're halving the amount of resources we use when we go from 80% to 90%. And if we're going to deal with climate change and these resource issues that we face, we have to go into this steeply rising part of the curve. And that's why it's important for us to do this. And in terms of consumption, of course, what happens is this is just a very basic demonstration of what happens if you've got a material where you generate 5 tons of CO2 per ton of primary material, and where in the secondary material when you're using the secondary material, the recycled material, you're generating much less greenhouse gases. And as we progressively substitute the secondary material for the primary material, we see the impact of our consumption reducing. And that's why we're talking here about moving towards a circular economy. We want the impact of whatever consumption we are still responsible for to be creating less effect. And clearly, as we go to a much more circular economy, the impact of that consumption declines. And this is recent work we've been doing with the Welsh Government, which has already set itself an ambitious target of 70% recycling. Not all of those climate change gains have been made, even at 70% recycling. We can go further. And even going from 70% to 80%, we still find a significant improvement can be made in terms of climate. And that's where we need to be moving if we're going to address the twin issues that confront our planet of climate change and of resource constraints. They're two parts of the same coin. So just to establish, point one, if it wasn't already obvious to people on the line, let's establish that recycling and waste prevention generally make good sense from the perspective of resource use and climate change. So let's go back to our residual waste issue. And when people are looking at residual waste, there's a huge range of technologies out there, and some of them, you know, you've got to be beware of who's selling you what. And the main ones, though, for quite good reasons, are incineration and landfill. Residual waste is a highly heterogeneous material. It's very varied. It varies from one moment to the next. And if you have a technology that's very sensitive to that composition, it's very likely to find difficulty dealing with that material, especially when so much is coming in day after day, hour after hour, minute after minute. It's a problematic material. Incineration and landfill are not simple technologies. Of course, they both evolved, but they're fairly robust in their own ways. So in a local context, recycling rates, as Enzo was saying, can increase swiftly. If you're in a municipality, you can move quickly from a relatively low rate to a relatively high one. More difficult to do that across a whole nation because you need to coordinate that activity. So national recycling rates tend to move a little slower than those local ones that can change really, really quickly. And I know Enzo can give you plenty of examples of that. But the further change, going from the 60, 70% to the 70, 80, maybe 90, that's going to happen a little more slowly. And so we've got an interesting trajectory here that people have to do a bit more work to get those harder to get at materials. Maybe in the future there'll be a clearer path for us to go from the low rates really to those very high rates in one jump. And so in that context, you're faced with this question: how much residual waste capacity do I need? And of what type? And these are really important questions that are being addressed by municipal waste managers literally day after day. So landfill, do you know one of the best things about landfill is it's what we call a stock facility. It's something that's there and it doesn't have a fixed throughput. It fills up over time. And it's, to some degree, you're not that worried about the pace at which it fills up. It doesn't completely drive the economics of the system. Of course it does to some extent. But if your facility is filling up slightly more or slightly less from one year to the next, it doesn't matter so much. And that's one of the best things about landfill, possibly the only good thing about it, is it's really flexible. You can put as much or as little from one year to the next as you're going in. So if you're in a situation where you're trying to develop your recycling system and you don't want to, you're worried about having too much residual waste treatment capacity or even too little, it's actually an interesting solution. But of course, we know it's not great from the perspective of climate change. And one of the big issues is the emissions of methane. And there's a long discussion we could have on this webinar about how effective landfills really are at capturing the methane that's emitted from them. And you get very varied views on that. But there are also other emissions to atmosphere, volatile organic compounds, polycyclic aromatic hydrocarbons. And then there's a question of leachate, which if it's not managed properly, and by the way, what's our time horizon? How long should we be looking at here? What sort of issues would we face? And then other impacts, disamenity. People generally don't like living next to them. There are good reasons for that. And quite importantly these days, if we've got relatively poorly managed landfills and lots of plastics arriving onto those sites, then those plastics can blow around and they can easily escape into the environment. A lot of work being done to understand just how much of that happens and to what degree in what places. Its key advantage, if you're looking at zero waste, is that it's flexible to the change in the quantity that you're sending there. The key drawback, though, of course, of it is its environmental impacts. Now, incineration is often touted, of course, as the solution. It is much more capital intense, as Enzo was saying. It may be, instead of being 250 or so for RMBT, it might be around €1,000 per tonne, maybe a little lower. But it's relatively inflexible in terms of the economics, in that it sort of commands a constant throughput. It's quite difficult to go to a bank and say, I'm going to build this incinerator tomorrow. Can I get a loan from you to build it? And if you're asking the bank for that money, they'll generally ask, okay, well, how much can you guarantee that you're going to be treating from 1 year to the next? And so what often happens, not always, but what often happens is that the nature of the contracts that are struck between municipalities and the operators of incineration companies is there may be an agreement to supply the material to that facility. And there may be even a minimum tonnage guarantee within that contract to ensure that that minimum tonnage underpins the financing of that facility. And so it can start to sort of pull waste in. And a lot of people say, well, incineration can undermine recycling. In terms of the environmental forms, it's quite interesting because Enzo was showing how the composition of residual waste might look. Composition of residual waste is really a fascinating issue because everybody tends to concentrate when they're talking about a particular material about what that means for the residual waste. But if I captured 70% of every material that was in the waste stream, I'd have 30% of everything left. And the composition of what I was left with would look exactly the same as what I started with, in principle. In practice, what tends to happen is people tend to be pretty good at separating out paper and card. They tend to be pretty good at separating out glass. They tend to be not bad at separating out metals. They tend to be good or bad at separating out food waste, depending on how good the service is. They can be very good at separating out garden waste. With plastics, interesting. They don't tend to be so good, and you can go and look at recycling rates for particular materials in different countries, and you'll find that plastics tend not to be so good because a lot of systems don't target the full range of plastics. And so what that means is that material that isn't captured as well gets concentrated in the residual. And that's what Enzo was showing with the plastics. You might start with, say, 10 to 15% in the total waste stream, but if you've got a high capture recycling system, you might have something like 15 to 25, as you were showing, in residual waste. What that means is when you're going to combust the residual waste, is you've got a material that has a significant quantity of fossil carbon in it, and that goes straight up the chimney, and it's contributing a significant amount of fossil-derived CO2 to the atmosphere. The other thing that happens, even under well-controlled situations, is it emits oxides of nitrogen. And so the European Incineration Directive has a limit value of around 200 milligrams per meter cubed of the air that's emitted from the stack. That translates into roughly a kilogram of NOx for every ton of waste that's burned. Well, if you go and look at the damages, health damages that are caused by NOx when they're emitted, they're of the order of 10, 20, 30,000 euro per tonne, depending on where you are. So for every tonne of waste that's being burnt, you have a health damage of the order 10, 20 euros per tonne that's actually associated specifically with the NOx. There are other emissions as well. There are the ash residues that Enzo mentioned, typically bottom ash, from which you can extract some metals, and increasingly people do. People are pretty good now at extracting steel and aluminium from those ashes, and some facilities look to extract other non-ferrous metals as well. But there's also a more hazardous residue associated with the air pollution control. And this is an interesting graphic I like on the right-hand side, showing how the significance of the air pollution control, the gas cleaning equipment, has changed over time. Wasn't much of it over 100 years ago. And progressively over time, the costs of this, and in terms of the overall plant, are really becoming very significant, precisely because we want to clean up the emissions from the waste. And roughly half of the capital costs these days may be associated with cleaning of the gas on a conventional incineration plant. The other impacts are, again, disamenity, and those tend to be even higher for incineration plants, partly because of where they're located, because the disamenity is partly a function of the housing density around the facility. So, is that a problem? I literally did this for this presentation today. This is all the local authorities in England. And on the left-hand side is the proportion of waste that they incinerate. And on the right-hand side is the proportion they recycle. Now, we've got a target in this country to reach 50% recycling by 2020 under European law. Well, all of these authorities are already incinerating 50% or more of their waste that they're collecting. So unless they're going to reduce the amount they send to their incineration plant, they're going to struggle to meet the 50% target. They ought to be, so if we want to get to our future target, 65% in the European context, they ought to be somewhere in this shape. That's where we want everyone to be. Just to go back again, there aren't many that are there. So, you know, we need all of our authorities to be moving in, to be getting into this triangle. And they might struggle if they're already involved in contracts that might be committing them to do more here. We'd really like them to get into this zone. We'd really like them to get into that zone if we're going to really address the issue of climate change. And what's interesting is 18% of waste collected by English local authorities is in places where more than 50% of the waste is incinerated. If I want to get to 65% recycling, well, I've got an even bigger problem facing me, because 80% of the waste that's collected by English local authorities is in the places where more than 35% is being incinerated. So everyone else doing the mathematics around that, the local authorities who aren't doing more than 35% incineration are actually going to have to do, if those authorities can't change the amount that they're incinerating and can't reduce that, then the remaining authorities don't have to meet 65% recycling, they have to do 75% for the whole country to get to the 65% target. And now the detail will depend on the contracts, but it shows how incineration can sort of get in the way. So I'm going to show you some pictures now about the greenhouse gas emissions from landfills and incineration. And in the modern landfill, only the non-fossil carbon degrades, so that's the food waste, the garden waste, maybe some paper card, maybe some wood. Some degrades over a long period of time. The fugitive uncaptured element, so we've usually got gas capture here in the body of the landfill to take out methane, which can then be used for energy generation and flaring. We can get some offset from the generation of that energy if we're avoiding the use of other sources of energy. And so the whole balance here of how well the landfill performs is a function of how much methane isn't captured, how much of the stuff that wasn't captured didn't get oxidized and converted into carbon dioxide as it went through the cap of the landfill. And on the other side, the positive balance, the positive contribution made from the generation of energy. Incineration, the input mix in, the majority of the combustible carbon is converted instantaneously. There's varying estimates of how much nitrous oxide you get from waste incineration. There's a higher than for landfill offset from the energy generation, and the amount of offset I get depends on how efficient the facility is and whether the facility is generating electricity or heat. And from the ash, as I said earlier, there's a contribution, a saving on greenhouse gases from the metals and the recycling. If I've got any uncombusted material in what I landfill, which I shouldn't have if the facility is operating well, I may find some emissions here. But that would be, we would be hoping to avoid that. So here's my greenhouse gas balance for an incinerator. I burn the waste, I get the fossil-derived material from the plastics, and I get the non-fossil material. And rule of thumb, it's close to a ton, roughly 50-50. Rule of thumb. Of course, it varies. There's some greenhouse gas emissions associated with the use of fuel. I get some benefit because I can capture some steel and some aluminium. And then here I've done the offset as though my facility is displacing electricity that would otherwise have been generated by a coal-fired power plant. And that's big because, of course, coal is a carbon-intense source of electricity. And so my net position is significantly influenced by this benefit that I get from generating the energy. And my net position, if I ignore, as international convention says I should, the contribution from the non-fossil element, from the food waste, the garden waste, and so forth, that position, I can almost say, well, look, I'm making a good contribution to climate change. It's great, isn't it? Okay, yeah, but that's because I was assuming I was avoiding generating energy from coal, and coal's a carbon-intense fuel. We're completely in a nightmare situation if forever we're going to assume that the source of electricity we're going to use is coal. In the United Kingdom, we have a schedule which is produced by our Department for Business, Energy and Industrial Strategy, which we use in policy analysis, which says, well, because we're going to be decarbonising the electricity supply, then when we're looking at what we're avoiding from things like incineration plants, we're going to be avoiding a progressively lower and lower carbon intensity source of energy as we go over time. And I would say most European countries are on some form of decarbonisation trajectory of that nature. And I would suggest many developing countries are now also recognising that the cheapest form of energy in many countries that are between the tropics is going to be solar power for the foreseeable future. So this decarbonisation is going to continue. So what does that mean? Well, it means that if I go to the 2018 marginal source, my energy benefit isn't anything like as big as it was when I assumed I was always displacing coal. And so suddenly my incineration plant doesn't look so great. And this is going to happen progressively over time. If you're saying that one of the key benefits of your facility is the generation of energy, you have to consider what the benefit of that might look like over time. That will vary depending on whether you're generating electricity or whether you're generating heat, because we expect heat to decarbonize slightly more slowly than electricity. And so it may be that a better option for incinerators, for example, is to be focusing more on the use of the energy as heat than as electricity. Go to something in the future where my offset is renewables, and of course I'm in a completely different situation altogether. If I compare that with landfill, which of course historically everybody says it's a complete nightmare from the point of view of climate change, well, we get into an interesting picture, because look at these last two figures. We're about 0.2 here and we're about 0.4 there. So somewhere as we're decarbonising energy supply, incineration gets from somewhere between 0.2 to 0.4. Well, here's my landfill when I'm assuming I'm displacing coal-fired power. It's at 0.29. And here's my landfill when I'm assuming it's displacing gas. It's 0.36. And this is assuming a gas capture around 50%. And many sources, US, UK, assume much higher gas captures from landfill than this analysis has assumed. So to sum up, you know, if we think the best option of those ones we've been looking at is where we are burning waste and we're assuming we're avoiding coal-fired power generation. But in the UK, we just banned coal-fired power generation. We can't claim that we're going to be displacing coal-fired power generation anymore. And if any one country is claiming that that's the background source of electricity, then frankly, we can all go home and live underwater in 20 years' time. We've got to face this crisis. So a landfill that has 70% gas capture, which is more or less what my government assumes, if I exclude the biogenic CO2, which is what the international approaches say I should do, then I'm basically into a pretty decent situation where I'm assuming I'm avoiding gas-fired generation. And at that point, I'm more or less in the same situation as as an incineration plant. A landfill with 50% gas capture is, of course, worse than a landfill with a 70% gas capture. And an incinerator avoiding renewables, wind-fired power generation, is worse than an incinerator that's avoiding gas generation. And a landfill with 20% gas capture is worse. But over time, that's the likely performance of landfills as they get better at capturing the gas. Over time, that's the likely direction of performance of an incineration plant, because the principal determinant of that effect is the decarbonisation of the energy system. So, as energy systems decarbonise, greenhouse gas benefits decline. Okay, we're in an interesting situation. Point 2. So, it's not the case that incineration will forever and always be better than a landfill. But that doesn't mean landfill's good. It just means incineration is not as good as it was in the past. So what's the best thing to do? So first of all, Enzo is talking about sorting waste. I'm not going to spend a lot of time on the technology, but what's happened is we've got far better resolution in the sorting, far faster speed of the sorting, cheaper sorting. And we can now get marketable outputs from the metals, from the plastics, and increasingly, even from mixed waste, we can take out waste, separate it by polymer and by color. We can then take it through a hot washing process and take it back to next to virgin quality material. Not just the extrusion that Enzo was talking about, but high quality polypropylene, PET if it's not already collected in a deposit scheme, and so forth. We can get high quality material through the hot washing processes. We can get some paper and card, we can get glass, and we can get some else. Of course, we don't get anything like the quality of paper and card as we get through separate collection systems. Of course, we don't get that. It may be more difficult to get really well color sorted glass.
Dominic, just to let you know that we start to be like below, like above time, like
yeah,
way.
I'll quickly go through to the end then. I'm going to show you.
Thank you.
Some comparisons when we put a mixed waste sorting facility in front of an incinerator. The effect on the climate change impacts. We see a significant reduction of more or less 0.4 tons of CO2 per ton of waste input. That's really significant. Guess what? We get something similar when we do the same thing on the front of a landfill. So the benefits are around same sort of figure, slightly less, because we've got a really significant impact when we put this at the front of an incineration plant, because we're taking out the fossil carbon that's going up into the sky. So mixed waste sorting improves the performance of both landfill and incineration systems. And for incineration, this improvement is really boosted by that removal of the plastics and the fossil carbon that otherwise goes up the stack. And the key point here is that no one should be sending anything anymore directly to a landfill or an incineration plant. So let's put the final piece on this jigsaw, because what was left of those emissions from the landfill, you can see here we still had on the landfill a significant contribution being made even after we've taken out all of this material. Now that's mainly methane. It's biogenic material that's degrading, and it's methane. It's uncaptured methane. How do we deal with that? Well, stabilization, as Enzo was talking about, is like a composting process. And this shows what happens to the tendency for the material to generate gas, methane, as we go through a treatment period within a composting type process. And it shows that we might have a material that tends to generate a lot of gas at the start. We compost it down, and actually over time it becomes much less likely to generate gas when it's landfilled. That's really important, because if we can convert this stuff that has a tendency to generate methane into carbon dioxide, which is a much less potent greenhouse gas, then we effectively address that landfill gas that we were talking about previously. So we can, through stabilization, this process of stabilization of the organic matter, end up with a material that has a sort of tendency to generate gas, a little like the organic layer of the soil. So it's starting to look relatively inert. And this, as Enzo was saying, can be relatively flexible, relatively low capital costs. The key point in terms of greenhouse gases is that the main greenhouse gas is carbon dioxide. As long as the ammonia that is part of the degradation process is scrubbed out before it goes into this thing called the biofilter. If it doesn't, that ammonia can be converted into nitrous oxide, which is a very potent greenhouse gas. And here's the schematic, but just to summarize the results. If I now put municipal waste sorting and stabilization together, I lose the vast majority of those emissions that were previously coming from the landfill. And now I've got the best performing system of the ones that I looked at. I've generated greenhouse gas benefits from taking out the material, and I've stabilized, I've removed the potential of the material to generate gas when it's subsequently landfilled. And in summary, here you go. Here's the 5 systems. Landfill and incineration on the left, and then municipal waste sorting plus landfill, municipal waste sorting plus incineration, municipal waste sorting plus stabilization. So, coming to the end, mixed waste sorting coupled to that stabilization, that compost-like process for residual waste, is a relatively simple option, which may be superior to incineration or landfill on greenhouse gas grounds, even when you've got mixed waste sorting in front of them. So finally, summaries for strategy. What did we learn? Mixed waste sorting improves the situation whether for landfill or incineration. But if we want a flexible treatment, we might not want incineration. But we might not want a landfill direct either. We've got greenhouse gases, we've got plastic from the blow-off of the management of the site. So step 1, mixed waste sorting. Step 2, stabilization of the organic fraction. Relatively low capital, potentially lowest greenhouse gases. So from the policymaker's perspective, please don't ban landfilling completely. Don't do it, because you end up tending towards pushing people towards incineration. Don't tax all landfills in the same way. You could do what they did in Austria and set a much lower rate for the stabilized bio-waste. So you basically set in a differential between the tax for the unstabilized waste and the tax for the stabilized waste that drives people to implement that stabilization process. Do think about taxing incineration, particularly the fossil-derived carbon dioxide, encouraging people to take out, through mixed waste sorting, the material that contains the fossil carbon. And do think about taxing those NOx externalities, because we have air quality problems in many of our cities, and we're tending to miss the fact that it's not just the transport sources, but it's also the stationary sources like incineration plants that contribute to that problem. And finally, please don't give capital grants to any residual waste treatment processes. And I think at the European level, we're starting to do a good job on that. And we don't want residual waste treatment to be cheap. Thank you.
Thank you very much, Dominic. And sorry, I've been like pushing you.
That's okay. I'm sorry I was late.
Yeah. So I invited to stop sharing your screen, and they were like a couple of questions, and we have more or less 15 minutes left. There was one question at the very beginning when you were talking about recycling. It's Alexandra who was asking, I didn't understand why recycling from 80% to 100% can exponentially decrease the greenhouse gases production. Why wouldn't the Pareto rule 80-20% apply here? Okay, can I just go back to the screen picture again? Yeah, sure. Because it wasn't actually the greenhouse gases, that picture. That was not a grid. It's this one, I think. So I wasn't talking about the greenhouse gases. I was talking about the resource use. So if I imagine I've got a ton of material that I've used to make a particular product. If I recycle that material at 50%, then from that material, I can make 2 tons of that product. If I go from then to 80% recycling, from that initial ton of material, I can then make 5 tons of that product. And then if I go to 90%, I can actually make 10 tons of that product. So I've doubled the amount of material I can make by going from 80% to 90%. That's because the mathematics of that is 1 divided by 1 minus the recycling rate. And 1 divided by 1 minus 0.8 is 1 divided by 0.2, which is 5. 1 divided by 1 minus 0.9 is 1 divided by 0.1, which is 10. And I can make 10 times as much stuff at 90% as I started with. I can only make 5 times as much at 80%. And that's why this graphic, I rather like it. We don't tend to think of recycling rates in that way. Thank you very much. Thanks for the clarification. There was a question from Jacques who was asking, he was wondering if you did the same kind of analysis between composting, methanization and vermicomposting. We have done that in the past, yeah. We've done most things. Yeah, I can't remember exactly what it came out with, but there were some studies being done in the UK in the last decade around that. We did some analysis. I can dig it out, and that tends to be, of course, of the separately collected material. We're talking more today about the residual waste. In terms of I can forward some analyses we've done on that in the past, particularly around, for example, benefits around anaerobic digestion versus composting, for which incidentally those online might like to know the benefits are strongly influenced by how you use the biogas. And again, going back to how much carbon you can displace through the use of the biogas, you're better off generally today trying to displace transport fuel. So you have to clean up the gas and then put into vehicles that can take dual fuel or CNG, compressed natural gas. Then you're probably better off putting the gas straight into the grid, directly displacing gas, but again, you need to clean up. Finally, probably electricity. Thank you very much. I think we have some time to take 1 or 2 more questions, so I'd be happy for our participant to drop them directly in the Q&A. There's something that both of you mentioned. Andrew, you mentioned that we want to avoid locking effect with incineration. Yourself, Dominic, your point 3 was saying that no one should be sending anything directly to either landfill or incineration anymore. And there's some people who are sharing what is happening in their countries. For example, in Lebanon, Dr. Rula is explaining that they ban landfills and are pushed to install incinerators. But I just wanted to ask, what should happen in places that already have incinerators in place? Because we understand very well in both your presentation that this is really not the place where we want to go, but for people who are already in that place, what would be the strategy? And maybe if you can give some examples also, Enzo, on what is happening in some places. So any of you to start.
Do you want me to go first, Enzo?
As you like it. As you like it, but anyway, yeah.
Yeah, you go.
This is a situation which is codified in the European communication on the role of waste to energy in circular economy. Basically, the communication singles out two typical situations. Those countries without incineration, and in that respect, it says, before planning for incineration, consider how much waste you will have, not next week, but in 30 years' time, because that's the normal operational life of an incinerator. But then it singles out a totally different situation, which may be considered right now in different areas across Europe with excess capacity for incineration. And this is a situation which is already affecting, for instance, the Netherlands and most of the Scandinavian countries, Denmark, Sweden, a few regions also in southernmost Europe, such as Lombardy and Emilia-Romagna. And for those situations, European communication recommends stopping funding incineration, taxing incineration, a moratorium on new incinerators, and starting phasing out existing incinerators. In this respect, for instance, the region Lombardy adopted in 2013 by unanimity a regional resolution whereby they tabled a decommissioning strategy from incineration. Of course, you can't do that on the fly and one day to the next one. You have to wait until the depreciation planning period is over. But then instead of revamping the incinerator and going for another round, another 20 or 30 years, just phase it out. And you send residual waste to the other incinerators, or you replace it by means of an MRBT site.
Yeah. Yeah, I think I think that represents the Commission view, and I think the other thing that people would want to be doing is looking at what's the nature of the contractual agreements going on there. Because, for example, we've been doing some work, it's not complete yet, but with a company looking at the costs and benefits in different situations of putting mixed waste sorting at the front of an incineration plant. At a new facility, there's no question that it makes sense. At a facility that's already there, who bears the costs essentially comes down to what's that existing contractual arrangement. And so there would be some negotiation to be undertaken. And to some extent, whether or not it makes sense to do so depends on whether other waste can be brought in when the capacity is freed up by the sorting or indeed separate collection. And so it is important that we take a more strategic view, as Enzo was hinting, about capacity overall. I think it's fair to say there's some discussion about whether regions, countries should be importing waste from outside. I think my personal view is, in order to enhance the flexibility of the overall situation for Europe, it probably does make sense for that trade to be allowed. And I would argue we've benefited from that in the UK in taking up some of that spare capacity that Enzo was talking about in the Netherlands and Germany. That's not with a view to permanently maintaining that capacity, but it makes it slightly less painful for the Dutch and the Germans as they phase out capacity, and it means that we don't have to build our own.
Yep.
Thank you very much. While just preparing the webinar, we also mentioned that there was another tricky question, and I was hoping for someone to raise it, and it was actually inspired by you, Dominic. It was, okay, we understand that in your final graph, the summary was showing that stabilized landfills are to be considered, but in places, I know our colleagues in Switzerland, they would be very afraid with that vision, because their main answer would be, we don't have much space for landfills anyway. So a bit similarly, what would be the answer for places where there's no space for landfills?
Me or Enzo? Enzo first again?
No, your time, Dominic. And I will put the icing on the cake.
I mean, you know, we were doing some work recently in Hong Kong, and of course Hong Kong doesn't have a lot of space, and there's some very interesting decisions going on about how you deal with residual waste in that situation, and there's a lot of pressure to build a new incinerator on one of the islands. I suppose I get slightly more sympathetic to that where the space is incredibly constrained, but I think, you know, there are still things that people can consider doing. First of all, let's make sure that everything is being done up front in terms of separate collection. Secondly, I think, going back to the point, even if you were going to build an incineration plant, I think it's necessary today in terms of the climate change argument to have mixed waste sorting there anyway, so you're taking a further chunk out of the material. So what do you do with what's left? Well, in certain situations there may be possibilities, and Enzo might comment on this, in making use of some of the compost-like output in certain applications. It may even be remediating a landfill that might be closing, so there. That might be part of how that material could be used. Of course, it wouldn't use the whole mass of material necessarily for the whole life. But you know, there may be situations where there really is a lot of pressure to build an incineration plant. If that's the case, my sense is that what you would want to be trying to do is sizing it so that you are only sizing it to deal with that proportion of residual waste that you are pretty confident you are not going to be able to deal with for the next 20 years, because you've got a long life asset that you don't want to really obstruct you doing better.
Thanks, Dominic. Enzo?
Yeah, if I may top it up, since the question was coming from Switzerland, was it?
That's from me.
It was from Dominic.
No. Yeah.
But the comment about the landfill did come from colleagues from Switzerland, but not only, Austria as well.
This is why I was referring to Switzerland. Actually, you know, Switzerland, from an historical standpoint, alongside Germany and Austria, have been the best countries in Europe and basically around the world when it comes to recycling rates. But a few decades ago, I would have said, the fact you are the best ones doesn't mean you are perfect. There's still a long way to go. Even when you get to 50%, you've still got 50 precious steps to take towards perfection. And even at 90%, there's a few municipalities in Europe, well, not a few ones, an increasing number of municipalities at 90% separate collection, but they are still 10 steps away from perfection. But let me go back to Switzerland. Basically, the first thing I would do in order to minimize landfilling, including landfilling of ashes and slags, would be to minimize residual waste. Unfortunately, also Switzerland to some extent had a lock-in situation, above all based on deliver or pay contracts and the fact that the incineration capacity is basically run by the same public waste management companies which are also dealing with separate collection. So basically Switzerland has been moving quite slowly towards increased separate collection rates. But if you consider Slovenia, I touched upon Slovenia not by chance, you know, because Slovenia is really jumping on top of the standings and is set to be the first country in Europe and worldwide to achieve the material recovery targets set by the circular economy package for 2035. Probably next few years, they will already be at 65% net material recovery. Just because they don't have any lock-in, they don't have deliver or pay contracts, and so they can fully deploy the potential of circular economy, waste reduction programs, reuse centers, separate collection, recycling, composting, and pay-as-you-throw, and so on and so forth. So the most important thing to be done, always remember the cookie and the cake. We are not landfilling percentages, we are landfilling tonnages. The best thing to be done is to minimize residual waste by means of waste reduction and separate collection. And in order to do that, we need flexible systems.
Thank you very much. We're going to close in literally 1 minute and 30 seconds, but there's a last question that we're going to take, and it's a very interesting one from Sylvia, who's asking, some classify as renewable energy the waste incineration energy production. I think it's a very juicy question, but I'm happy that it was raised. So in a few seconds to maybe, yeah, as a teaser for a longer webinar, probably.
It's yours, Dominic, or?
Go ahead. I'll follow.
Yeah.
Well, okay, I'll go. For me, the concept of any form of energy from waste actually is being renewable. To me, is slightly crazy. It's a bit like saying we want waste to be a renewable resource. Well, I think that's a bit crazy. I don't want waste, full stop. And the idea that it should be considered a source of renewable energy, to me, is manifestly incorrect. If you look at, of course, people tend then to say, well, actually, there's some of the energy being derived from the non-fossil and renewable sources of materials in the waste stream. Even then, though, I mean, we can't surely be saying we want waste to be a renewable resource. It may well be that it's, for whatever reason, people consider it to be more benign than the fossil-derived ones. I think that's slightly, it flies in the face of the waste hierarchy, and it suggests that we would not want to be effectively minimizing waste in the first place. And I think we should.
Thank you, Dominic. Enzo, any final word before we wrap up?
No, this was terrific, and I'm very, very happy with this webinar. And well done, Dominic. But we are always happy, although never satisfied. But happy, very, very happy.
Thanks, Enzo, and thank you.
Yeah, thank you very much. I'm really sorry we have to close it here, and I know we have more questions, but we're still here and we run these webinars once a month. And I really want to thank you both, because when we picked the topic, we're a bit like, oh, that's kind of tough, hardcore topic, but very much needed. So
it's a dirty job, but somebody has to do that.
Exactly. So thank you for volunteering for that job. For the participants, thank you for joining and for being very with your questions, but also the feedback. So our next webinar is going to be on the 7th of May, and we're going to climb up again the zero waste hierarchy and talking this time about setting up a reuse strategy at the local level. I very much also invite you to see, we are currently organizing a study tour in Slovenia that will take place 8th, 9th, and 10th of May. Registration are closing at the end of the week, so please have a look. And in any case, to be updated on all the zero waste cities related topic, I invite you to sign up for our newsletter. And again, thank you very much to both of you for your time and your presentations that we will share to all the participants.
Thanks, Ezra. Thanks, everybody.
Thank you.
Bye.
Yeah. Bye. Thank you.